So now we are going to look at different ways to make your design even more compact. Alright, so we look here to the first one. So this is the first one. Right, you have two transistors in series, right? So you can put, in usual fact is that usually you put two transistors in series. You can do it like this, two transistors, one poly here, one poly there, and this is A and this is B, right? Because they have a connection in between them, right? This connection is represented here, right? So they are connected together. You can make the design even more compact by merging the diffusion. So you can put one diffusion with two poly, and it is the same or equivalent to this one on the left. So this is A and B. So this way you have smaller area. Alright, so this is only can be done when they are completely in series like this, right? So they can share the pattern region, and this reduces the layout area and the complexity. Okay, in the cross section, this is the cross section version. You can see that the diffusions are like this. Okay, so if you have them in parallel, these two are actually in parallel like this. This is A and this is B, right? And this is X and this is point Y. When you expand them, they actually look like this, right? So this connection here is Y, and this connection is X. Okay, when you draw them out, you actually put them two side by side like this, A and B, right? And you can put the metal connection here, and they have another metal connection. This is for X and this is for Y. Okay, so you can shrink it by moving this closer together, and the same way you did for the top part here, you can shrink and combine them, right? So the X goes in the between. There is no need to run a long wire. You can make it a short wire. So the idea is, when you want to make it compact, you want to reduce area, and number two, shorten wires. Okay, so let's look here. This is the layout of a 2-input NAND. We can draw the 2-input NAND also in the layout. As you can see here, the NAND gate has the NMOS in series. So the NMOS series is reflected here. These two are in series, and the PMOS is in parallel. So this PMOS is in parallel here. You can see the connection here like this, and this is A and this is B. So this is in series, and this one, the connection here is in parallel, right? So here we put in a NAND gate. This is a NAND gate, but if we want to have an AND gate, what we need to do is very easy. You just put in a inverter. So this one is actually a NAND gate, 2-input NAND gate, A and B connected to an inverter to form an equivalent to an AND gate, right? So this part here is the NAND, and this part is the inverter. Okay, So you just cascade and you put the output of the NAND gate here, out 1. This is out 1. And you put it as the input to the inverter, and you have out 2 over here. Okay, so this should help you in your lab.